Hi. We are going to continue with rationalizing the denominator. I crumble under pressure. We started this yesterday, and we kind of introed talking about the reason why we need to do this. And it all comes down to the fact that we cannot have a radical in the denominator of a fraction because that is an irrational number, and the denominator of a fraction must be rational. So if we have something like 2 over the root of 3, okay, our process to rationalize this is we're going to multiply the fraction 2 over root 3 by the root we want to remove, which is root 3. That's the problem root, right? That's the problem. And the over itself, okay? And who remembers what two things this kind of accomplishes for us? Or what two things, why does this work? Let me put it like that. Sydney?
When you multiply the two bottom ones, you get square root, and then when you divide them, you get 1.
Right. When we multiply those denominators, root 3 times root 3, we get a perfect square. We get root 9. And that's going to happen every single time. And if you have a perfect square in the denominator, such as root 9, that's good for us because that just equals 3. Okay? Essentially what happens here, and you probably picked up on this, is that when you multiply a root by itself, that root just goes away. And you're left with, in this case, 3. Okay? In our example from yesterday, when we multiply by root 7 over root 7, we were left with just 7. Essentially, it just cancels out the root. Right? And then what are we left with in our numerator? 2 times root 3. Is that like 6 or root 6 or... Blake? Right. We can't combine them because one is outside the root, the other one isn't. So there's nothing we can do. It's going to stay 2 times the root of 3 over 3. Can we simplify those 3's? Why not? I was pointing to Will, but
all right. So since you can't get the square root of 3.
Right. It's the same reason why we couldn't multiply 2 and root 3. One's inside the root, the other one isn't. Okay? And so this would be our final answer. Okay? And on the test, if you've got no variables to deal with, checking your answer is actually relatively simple. If you go to your original expression and in your calculator you type in 2 divided by the square root of 3, you're going to get a nasty decimal. That's okay. You're then going to take 2 root 3 divided by 3 and make sure those decimals match. Because you're not changing the value here. Because what's the other thing? Not only does root 3 over root 3 cancel the root, but what does root 3 over root 3 actually equal? 1. And when you multiply something by 1, the value doesn't change. So as long as you can verify that these decimals are the same decimal, you did it right. Okay? So, we went through one of those yesterday, went through one today. No doubt you are experts and ready for your homework. I'm just kidding. Yeah.
Couldn't we just do 9 the root of 5 times 5? Couldn't we just do that instead of having to do all the work and multiply it out?
Well, Peter, if I only gave you the answers to every single thing, then you'd be asking, well, how'd you get that? Right? Once you're able to do it mentally, that's the ultimate goal. Some of you get there. Some of you need to show some work. That's okay, right? You know, I can't mentally simplify something like these last bottom two. I've got to show some work just because I lose track of numbers and things like that. So if you can do some of this without showing every step, eventually, great. Am I going to ask you to show your work now because you're first learning it and you're likely to make mistakes and it's a lot easier to see what those mistakes are if the work is shown? Yes. Right? But yes, I mean, obviously, you know, yeah. Anyway, does that answer your question? Okay. 9 over root 5. What are we going to multiply by to rationalize this denominator? Sydney? Root 5 over root 5. Yeah. Root 5 over root 5. And so maybe this is where Peter's saying, well, can we skip some steps now? You know, if we recognize that root 5 times root 5 is just going to give us 5 because we understand that either A, the root cancels out, Or B, root 5 times root 5 is the root of 25, which is a perfect square, gives us 5. Maybe we don't have to show that intermediate step. And if we know that 9 times root 5 is 9 root 5, there would be our final answer. 9 root 5 over 5. Okay? Go ahead and do the last two on your own. 8 over the root of 15 and 1 over the root of 10. I'll give you about 30 seconds to do that. And then we introduce variables and other quirks that we need to keep in mind here. Who would like to share their answer for 8 over the root of 15? Joey.
Yeah, so 8 times the square root of 15 over 15.
That is correct. 8 root 15 over 15. How we get there is we're taking our original fraction, we're multiplying by that root in the denominator over itself. We know that root 15 times root 15 is going to cancel out that root, giving us 15. And then 8 times root 15 can't do anything with, so we leave it as 8 root 15, and there's our final answer. How about the last one? 1 over root 10. Carolyn.
I got 1 times the root of 10 over 10.
1 times root 10 over 10. If you wrote that without the coefficient of 1 and just put root 10 over 10, that's fine too. Either one is acceptable. But yeah, same kind of deal as these first few. We're just dealing with the numbers to start with here. Multiply by root 10 over root 10. Our denominator, root 10 times root 10 is root 100. Perfect square equals 10. And then our numerator, 1 root 10. Or just root 10. Questions so far? Okay. So let's look at the second row. 6 over 3 root 10. Now, that 3 in that denominator, it's actually not a problem, right? Because 3 is a rational number in and of itself. So if you want to multiply first, you could just go and straight away multiply by root 10 over root 10. What else could you do to start this? Will? You could also simplify your 6 and 3 here, because both of them are outside of the root, therefore they can be simplified, and 6 over 3 would give you 2 over 1. At some point, you'll have to simplify, whether it's now or later, doesn't really matter, but at some point you do. Personally, I like to simplify first, because it typically makes your numbers smaller. It makes it just less messy, okay? So let's start with that. Let's simplify our 6 and 3 to be 2 over 1. Or just 2 over root 10. If you don't want to write the 1 root 10, but you can see how I got there. 6 over 3 simplifies to be 2 over 1. Now I'm going to multiply by my root 10 over root 10. And what's my final answer? Mackie.
2 times the root of 10 over the root of 10.
Not the root of 10, 10, right? Cancel it out. Are we done? No. Drew, what can we do?
Simplify the 2 and 10.
Yes, we can simplify our coefficients here, 2 and 10, because they're both outside the root. That's the key there. And 2 over 10 simplifies to be 1 over 5. So our final answer is going to be 1 root 10 or just root 10, either one's fine, over 5. Okay, so couple simplifying things we needed to do here. If we wait till the end to simplify, kind of see how that changes things. Let's do that here. You don't have to write this down if you don't want to. But if we keep our original fraction of 6 over 3 root 10, we're still going to multiply by root 10. We don't have to multiply by 3 root 10 because the 3 is okay. And what that's going to give us in our numerator is 6 root 10. What do you think is going to go in our denominator? Because even though we didn't use the 3 in multiplying, we can't just ignore it. It's still there. Any guesses?
30.
Well done. 30. How we got 30 is our root 10 times root 10 is root 100, which equals 10, right? Same thing that happened here. But since that 3 is still there, we have to multiply that 10 by the 3. And that's where we would get 30. And if you'll notice, 6 root 10 over 30, that's 6/30ths, simplifies to be 1/5, just like our first one did. Okay? So you're going to have to simplify at some point. Where you do it at the start or at the end, in the middle, doesn't really matter. It just kind of depends on what you would prefer to do. But if you leave that coefficient there, don't forget about it, right? Whatever that root times the root is, you need to multiply by that original coefficient. Okay? All right. Next one, 12x over root x. Our root is a variable. Can we simplify the root of x? Not the root of x, right? That's the one that's already in simplest form. So what are we going to be multiplying by? To rationalize. Not x. The root of x over the root of x. Okay? Whatever root is in the denominator, multiply by that over itself. Because it equals 1. Ooh, it equals 1, so we're not changing the value. Okay? But root x times root x gives us the root of x squared, which we know equals x. It gives us that perfect square. It will every time. Okay? Our numerator, 12x times the root of x, we can't combine that root x because it's under a root. So it's written as 12x root x. And we be done? No. Why not? Caleb? We can simplify the x because both of them are outside of the root. And so our final answer, since our denominator is gone now, is just 12 root x. Okay. Questions on those two? Okay, the next one, 7 over root 8. Tell me about that root 8. What are our options here to rationalize or to simplify this? What are our options? Is root 8 a perfect square? Can it be simplified? Yes. We could simplify the root first, or we could simplify later at the end. What do you want to do? Schleifer, I'll pick on you. Do you want to simplify now or simplify later? Now. Very well. So the root of 8 simplifies to be what? The root of 8. 2 factors, 1 being a perfect square. How does that break down? Blake? Root 4 times root 2, which ultimately becomes 2 root 2. Okay. Hopefully simplifying those numerical roots at this point is getting to be more mental for you. It really kind of depends on how well you know your factors and how well you know your perfect squares. If you're comfortable with each of those, then it's probably a fairly quick process to come up with what your factors are. If you aren't, then maybe you still need to jot down some work or whatever. As long as that you know what to be doing, that's at this point, I hope we're close to that. So we have 7 over 2 root 2. What are we multiplying by to rationalize that denominator? Gino?
The square root of 2?
Right. Over the square root of 2. Okay? We don't need to multiply by 2 root 2 because that 2 is good. Okay? That coefficient of 2 is okay. We can't forget about it, but it's okay. So our numerator, 7 times root 2 is just 7 root 2. Our denominator, root 2 times root 2, there's our perfect square. right? That's what we want. We get root 4. The root of 4 equals 2. But here's where we can't forget about that original coefficient, because this is still here. And we're multiplying 2 by 2. So our denominator is going to be 4. Is that sitting okay with people? Where everything comes from there? And again, going back to Peter's question earlier, why do I show all these steps? Well, if I started with this and just wrote down the answer, okay, how'd you get there, right? The work is how you get there. Yes.
How would you simplify it from the end?
So if you didn't, so I'll do the work up here so I don't erase this. If you didn't simplify first, then you start by multiplying by root 8 over root 8, which would give us 7 root 8 in our numerator and 8 in the denominator, right? Where would you go from here to simplify? Simplify the 8, right? So the root 8. So in your numerator, now it would become 7 times root 8 simplified is 2 root 2, which equals 14 root 2 over 8. And now what can you simplify? Joe. The 14 and the 8, which simplifies to be 7 over 4, right? If you divide each by 2. Right? So that's how it would look. Okay? You'd simplify the root 8 in your numerator and combine it with the 7 there rather than denominator. The last one, 2 root 10 over root 80. Ugh. We've got some options here, though. What do you see? McGarry? You can simplify the roots. I'd much rather deal with, what would root 10 over root 80 simplify to be? 1/8, right? Or 2 root 1 over root 8. Just like the fraction 10/80ths is 1/8, the root of 10 over the root of 80, this would simplify to be 2 root 1 over the root of 8. I'd much rather deal with that than root 80. And even better, do I have to have that root 1 there? No, because the root of 1 is 1. So really, I can start this as 2 over the root of 8. And now it's very similar to the one we just did, right? Where you got that root 8 in the denominator. You can do it now. You can simplify now. You can simplify later, right? But starting this with simplifying that 10/80ths here is essentially what we have. Simplifying that to 1/8, and especially I don't even have to write the root 1, we're in business. Okay? Let's see. Who can? John, now or later to simplify? Now. Very well. So starting this the same way as we started the last one, we're going to simplify that root 8. Those two factors, one being a perfect square, 4 and 2. It gives us 2 root 2 again. Ooh. Ooh. What do you see? Anything interesting? Anything stand out to you? A lot of 2s, yes. As a mathematician, I want you to always look for those opportunities to make the expression simpler. At every step along the way, can I simplify? Okay. What can we do here, Peter?
Simplify the 2 and the 2.
Right. These two 2's simplify to be what? Well, not nothing. They simplify to be 1, right? So we have a 1 in our numerator and a 1 root 2 in the denominator, right? Because 2 over 2 is equal to 1 over 1. Do I need the 1 in the numerator? Yes, because it's the only thing up there, so I have to keep it. Do I need the 1 in the denominator? No. So again, I can kind of just eliminate that, and I'm left with 1 over root 2, which now that we're at this point it's just like these number ones that you had up at the top, right? We're going to multiply by root 2 over root 2, and that gives us root 2 over 2 as a final answer, which we can't simplify because 1, 2 is under the root, the other one isn't. How we doing? Okay? So? Okay. If anyone would like to share kind of where they are getting stuck along the way or any step that's not quite grasping. Yes?
So I have 2 root 1 over 8. And then the next step is 2 over root 2 over 8.
So you have this step here, right? And what's your next step? You said? What did you say your next step was? Well, where we went from here, do you know, was I just kind of ignored this root 1 and rewrote this same expression here. But instead of 2 root 1 over root 8, I just put 2 over root 8 because I don't need the root 1 there. Okay? And then from there, I simplified my root 8 to be 2 root 2 using the factors root 4 times root 2. And then we notice, hey, we've got a 2 in the numerator and the denominator. 2 over 2 simplifies to be 1 over 1. Can you pick it up from there? You good? Okay. Anybody else? Okay. Let's look at the last row here. And this is going to be where your homework comes. So you will have an opportunity for the number game tomorrow. Your last chance if y'all finish the homework and then take a lot of risks tomorrow. That's the key to victory. Lot of risks. Lot of risks. What do we remember about the root of a fraction? What does math allow us to do to it to make our lives a little bit simpler? Anyone haven't heard from me yet today, perhaps? No? All right. Well, yes, we can split this up. So it's the root of 28 over the root of 5. Okay, the root of 28 over the root of 5. Now, we're not taking the root of the whole fraction. It's just the numerator and the denominator separately. Where do you want to go next here? I've got a recommendation, but where would you like to go next? Thomas? Oh, sorry, I thought that was a hand up. Our options are any simplifying we can do anywhere or rationalizing. Do you see anything that we can simplify? Drew? Okay, Peter?
We can split up the 28 and the square root of 4 times the square root of 7.
Yes, we can simplify that 28 using the factors root 4 and root 7. Root 4 being that perfect square, which gives us in the numerator now 2 root 7 over root 5. Okay, basically all that does for us is it allows us to, now when we rationalize, multiplying root 7 by root 5 instead of root 8 by root 5. But why that does matter is because 28 times root 5 is root of 140. It's a lot easier to simplify the root of 28 than it is to simplify the root of 140. Okay, so simplifying first kind of makes this just a smaller numbers thing. Right? But now we're at the point where we rationalize, so we multiply by root 5 over the root of 5. The root 5 can be multiplied by the root 7 because they're both under a root. So we get 2 root 35 over 5. Because remember that rationalizing, what happens, root 5 times root 5 is root 25, perfect square, and we get 5. And that would be our final answer. We cannot simplify the root of 35. Its factors are 5 and 7, no perfect squares. And so we're stuck there. We can't simplify the 2 and the 5. They're already in simplest form. Done. Okay? Done. We've got time to go over one more of those three together. Which one would you like to do, Violet? The last one. 18x, the root of 18x cubed over 28. I'm going to recommend we simplify this first. Okay, I'm gonna start with that. So remember, I'm going to do the work down here. We can divvy this up to be the root of 18x cubed over the root of 28. I'm going to focus on that. So that root of 18x cubed, if you remember from previous lessons, we deal with this by splitting up our number and our variables, right? We split this up to be the root of 18 times the root of x cubed. Okay? How does the root of 18 simplify to be? Two factors, one perfect square, break it down. What you got, Blake? 9 and 2 are the factors, so ultimately it becomes what? 3 root 2, right? That 3 coming from the root of 9, which is the perfect square factor that goes into 18. And then how does the root of x cubed simplify to be?
X squared root x.
Not x squared root x, just x root x. Okay? The factor is the root of x squared, but that simplifies down to be x. Right? So now we look at what's outside the roots, 3 and x. That's going to stay outside the root. And then what's inside the root, root 2 and root x, is going to stay inside the root. So our numerator ultimately simplifies down to be 3x root 2x. And we got that by first simplifying the root of 18. Root 9 times root 2 gave us 3 root 2. Root of x cubed, root x squared times root x gave us x root x. Put it all together. 28, we just did that. That gives us 4 and 7, which becomes 2 root 7 there. Okay? Now to rationalize. What do we do? What's our next step? What are we going to be multiplying by here? Schleifer? Well, to rationalize, we focus on what's in the denominator.
2 is the root of 7.
And do we have to use that 2? No. The 2 is good. It's only what is under the root that we need to multiply by. So it's only going to be root 7 over root 7. We can't ignore the 2. It will come back, but not in this step. So our numerator, who's got a I don't want to say a guess, but who's got an answer for what our numerator is going to be after we multiply by the root of 7? Will? Good. 3x root 14x. Because that root 7 times root 2 can be multiplied. And then our denominator, root 7 times root 7 is root 49, which equals 7. But what do we got to remember, Thomas? We have to multiply by 2, right? That 2 didn't go away. And so 2 times 7 gives us 14. Are we done?
Yes.
In this case, we are. Yeah. We can't simplify the 14 and the 14. One's under the root, the other one isn't. There's nothing else in the denominator we can cancel out. This would be your final answer. Okay. Really focus on the steps. This is something where some of you have made it this far without showing a lot of work. There are a lot of details here. Lots of steps, lots of details. Show the work. Okay, Caleb.
We should concentrate on
Good. Hold on.
Hey, for a last lesson.
Okay. Yeah, yeah. Okay, so simplify each expression. Your homework is the last two for tomorrow. And for the last time this year, that is how you math.